Good. My name is Sadiq Jaffer. This is 3 steps for OCaml' to crest the AI humps. Have to have a camel reference in there somewhere. So, to begin with, 0.003%. What is that? That is the amount of OCaml' code there is in version 2 of the stack, which is a code corpus that is used for pre-training for a lot of large language models. And that's really not very much at all. Like, for reference, Python's about 10%. And what is the impact of that? Well, a paper last year found that there's about a 5 times performance difference when trying to solve a problem in Python versus OCaml'. And what I believe, and what I'm arguing in this talk, is that the performance disparity between code agents in mainstream languages and in niche languages is an existential threat to the communities around those languages in the medium term. Newcomers will not only be judging a language by the traditional tooling, compilers, linters, etc., static analysis, but also in how well coding agents are able to perform in that language. And in this talk, I'm going to go through 3 steps that we can use in order to try and narrow that gap. So step 1 is we should determine where agents are deficient for our own use cases. Step 2, we should then contribute to public benchmarks with those use cases we care about. And then step 3 is, as a community, we should work together to build agent-friendly documentation and tools. And for each of these steps, I'll give you an example of what they might look like. So step 1, it's determining where there are deficiencies at the moment. And the example I'm going to give, so to understand where the deficiencies, you need to measure performance for the use cases that you particularly care about. And so an example for us is we wanted a language model and a coding agent that first-year computer scientists could use to help them through some of the coding exercises on our first-year computer science course. And so we wanted something that could run locally or on university servers. We wanted to support the teaching environments. We wanted reproducibility and provenance. And also we wanted something that we could fine-tune, something maybe where we could have a gradual increase in capabilities as students progress through the course. So what we did is we took the interactive coding exercises that students already did. These are in a Jupyter notebook, and these are part of the Foundations of Computer Science course. And we used these as our benchmarks because they were directly relevant to our use case. So what do these look like? So essentially the student has a Jupyter notebook. They're asked a question. The questions become progressively harder. They essentially fill in the little bit of the solution box where we've left a comment, and then there's a number of tests that test that actually their solution is correct. And so this is an example where the students need to return the intersection of 2 binary search trees. So we adapted this to we adapted this so that we could run coding agents against it, and then we swept over a large number of large language models powering those agents, and we produced these results. So we used Claude Sonnet 3.7, which at the time we did the experiments was the kind of frontier model, state-of-the-art performance. And then we compared it against a whole bunch of other language models that were small enough that we could conceivably run it internally inside the university on a server and still allow for concurrent use by students. And what we found, actually, is that the Qwen3 model, which was just released at that point in time, performed far better than we expected. At 32 billion parameters, you can run it even on relatively affordable GPUs. What we found was that reasoning significantly improved performance. As you can see there, the difference in performance is quite remarkable. And actually, Qwen3 approached Claude Sonnet, which at the time was a lot more expensive proprietary model that couldn't be run on local machines. Reasoning significantly improved performance, but it's not free. It comes with costs. So it increased latency because you're generating all these reasoning tokens, and then that generation means it's more expensive to run. But that's an example of where we had a use case, and we came up with our own benchmarks to establish how well models performed, and then we looked at what the deficiencies were. So one of the common things we saw was that small models actually made lots of syntax errors, which was surprising even for smaller models. There was a lot of type system confusion, so they would try and use floating point operators with ints and vice versa. They tended to hallucinate a lot of functions that just didn't exist in the standard library, and many of the models actually assumed that core was available, even though it wasn't in those notebooks. And lastly, they all kind of seem to struggle with recursion. Some of the models failed to use the rec keyword correctly. Part of that is probably the autoregressive nature of generation, where they'd get to the end of a function and then panic because they hadn't done something earlier on. But many of the models also had incorrect base cases. So that's an example of figuring out your use case and then evaluating models and agents for those use cases to understand where they work and where they don't. Step 2 is, once you've done that, is to find public benchmarks to contribute to. And then take your use cases and contribute these to public benchmarking projects. So there are lots and lots of different public benchmarking projects. There's things like Big Bench, Human Eval, Humanity's Last Exam. Some are named grander than others. There are things like SWE Bench and Terminal Bench. And what we should do is take the use cases we care about and contribute them to these benchmarks, because actually the creators of the benchmarks want to find hard things that models can't do at the moment. And we need to make sure that our use cases are represented in those benchmarks. So I'll give you an example here. For reasons, I spend a lot of my time maintaining the OCaml' garbage collector, and I spend most of that time in GDB debugging the GC, because it's quite easy to make it segfault. And so I decided, for what might turn out to be very short-term reasons and not good for my long-term career, I decided to contribute a GC task to the Terminal Bench project. So I introduced a bug into the OCaml' GC in a fork, and it's a bug that you can't find publicly, but it's very, very similar to a mistake that I made when I was adding a feature to the OCaml' garbage collector. And I then put together a task where essentially I said, I've been hacking on the OCaml' GC, and oops, I've accidentally made a mistake. It's segfaulting. Please help me figure out what the problem is and fix it. You will need to read the hacking.adoc documentation, and you will need to build the compiler, run the test suite, debug the problem, fix it, and then verify the fix by looking at by running the basic test suite. It's quite a difficult task, and so far the agents don't really love it, because I've been watching the GitHub repo for Terminal Bench, and there's been a number of PRs that have kept bumping the maximum timeout on that task. And I think we're up to a couple of hours at the moment, so probably burning a lot of GPU somewhere trying to solve this. But this is an example of where it's a use case that models are not very good at the moment, and where we want to improve it. And what these AI labs do, because they report their scores on benchmarks like this, is they put a lot of time into synthesizing new examples that are similar to try and improve the model's performance on these benchmarks. So if there are use cases that we have, we should get them into these public benchmarks. And this isn't a one-off process, right? The problem is these benchmarks, they get saturated. Some of the labs will overfit them by trying to train their models on similar problems. They get leaked, accidentally. People give a OCaml' workshop talk about them, which ends up on YouTube, and then the transcripts from that end up being in the training data or that kind of thing, so you have to be careful about what you're saying. But eventually they get leaked, and so they become saturated, and then people move on to other benchmarks. So it's a continuous process. So if you have a bunch of your own carefully curated benchmarks, don't put them all in immediately, right? Step 3, tools and documentation. So there are ways that we can, models are never going to have, there is never going to be enough training data out there that models are trained on to ensure that there's enough parametric knowledge about OCaml in model weights. So what we have to do is we have to bridge that gap by making sure that we kind of provide a crutch for agents. And there's two main ways that we can do that as a community. First is agent-friendly documentation, and the second one is supplementing the agents by giving them tools that mean that they can better manipulate OCaml code bases and they can better navigate them. So when it comes to agent-friendly documentation, this is, if you go to ocaml.org and in fact, I don't even know what bytes labels. So if you go there and you look at this is what you see. This is what the LLM sees. It sees all the content mixed in with a whole bunch of markup. And this is a bit of a problem because the LLMs will kind of pull that into their context. And context is a valuable resource, right? Although, the sticker context for a language model can be up to 1 million tokens, what you'll probably find is as you start to get past about 100 to 200,000 tokens, the actual performance nosedives, right? There's just too much in there for the language models. And so it's quite important that when LLMs are pulling in information, we try to give them just what's necessary and not extra cruff like a bunch of HTML markup. So what we should show them is we should just show them the markdown version. Now, I understand there's some very recent progress on this, and we were talking about it about 5 minutes ago. So it's just been merged into ODoc, and so now ODoc is actually able to produce markdown versions of the documentation. There is an LLMs.txt standard, which essentially provides a kind of LLM-friendly documentation and help in a way that also can be navigated by LLMs. There's also another proposal to enable markdown versions of any HTML page. So if you just append .md to it, you should get markdown. And many agents now are able to do that. And that's something relatively simple we can do as a community to make sure that actually agents can work better on OCaml code bases by being able to get documentation easier. The next thing is tooling. So an example here is ODoc LLM. So ODoc LLM is MCP. So for MCP is the Model Context Protocol. So the big kind of change in the last 2 years has been how good language models have got at using tools. They can correctly use them, and they can use them to solve problems. And they've gone through a lot of reinforcement learning to do that. The problem is actually letting agents understand what tools they have access to and how to use them. And so the Model Context Protocol is a way of doing that. And you can create what's called MCP servers, which you can add to your agent, and they communicate to the agent that you have these tools that you can use, and here's the documentation for these tools, and then you'll find the LLM will go off and use them. So ODoc LLM is a prototype that John Ludlam and I created. It essentially takes ODoc's documentation. It then does hybrid search, so it embeds all of the documentation for a package. It also builds a hierarchy of documentation, so it kind of recursively summarizes it. And it then does a sparse keyword-based search on that. And it gives 4 different tools for an agent. It allows searching packages by functionality. So you can say, I want an HTTP 2 server that can do something. And it will give you back a number of packages that could do that, which then the agent can look at and can try and install. And the reason for doing that is because these LLMs haven't seen a whole bunch of packages out there in the wild. So they don't really know if a new package is developed. They don't know they have access to it, or they could install that. It does search by functionality for modules. It allows you to get a concise summary of a package. And it also allows you to search docs using Sherlock code. So you search the documentation for modules that are in your local project. One of the problems is finding functionality is hard. So it's not clear actually like what package you should recommend to a user. Do you recommend a broad, large package that contains that functionality, or a very specific package that only has the functionality that the user wants or the model wants? That's not entirely clear at the moment, so there's still some research to do there. Just recommending the most popular package doesn't really work because you tend to then only recommend really large packages that are widely installed. My colleague John has written a blog post, if you're interested in that. He also links to a few other bits of work happening in the community that are linked to this. And this is the GitHub URL, but I should point out it really is a work in progress, but collaborators are welcome, and maybe this can join up with some of the other work that's happening in the community. So I'm going to recap. So I believe that the performance gap between coding agents on mainstream languages and niche languages is going to be a problem in the medium term. Right? There's not really much we can do about the amount of training data there is for OCaml' out there. And so we've got 3 steps. First is we need to understand where they are weak for the use cases we care about, and everybody's going to have slightly different use cases. We need to then contribute to public benchmarks with those use cases. And then we need to try and bridge that knowledge gap by providing agent-friendly documentation and tools as a community. And that's something that we need to do, that we need to coordinate and do more work on. And by doing that, we can hopefully narrow that gap. Thank you very much. Questions?
Thanks for the talk. I'm interested in the MCP part of this talk. It feels like there's an opportunity to expose more like Merlin or more typing information via MCP, because I've found in using I suppose these sorts of tools, they tend to try and write Python or JavaScript in whatever language you ask them to write it in. And so, giving them more type information would be useful, but also the type information that we get as programmers is via the error messages. And there's like a richer representation of type information in the type system that we could be giving to these tools. So have you thought about that?
Yes. So I mean, if you've used Claude Code on an OCaml' code base, you see it sits there grepping the code base, and you're looking at thinking, well, there's a much better way of doing this. And I think we need to provide that and make sure that there's a good kind of out-of-the-box experience for users in doing that. There's been a lot of progress, like a lot of announcements in the last week or two of plugins and marketplaces and that kind of thing. But it may be something that we want to think about as a community, is having a centralized kind of plugin that works out the box, that we know works, and that gives you Merlin, Shallow Code, those kind of plugins, so that bridges the gap.
Cool, thanks.
And the other thing I was going to mention as well is that clearer actionable error messages are actually super crucial, because if you watch Claude going, it will compile something, it will get an error message, and then it will try and figure out what to do. But clearer error messages seem to have, there's a lot of history around error messages with the compiler, and so there's still more work to do there.
So when you mean clearer error messages, like a lot of the work in error messages is around making them more understandable to people. Like, we're not trying to describe these error messages to people. Do you have a sense of, like, should we be more concise? What's a better error message for like one of these agents?
I think a good error message for a human is probably a good error message for an agent. Like, I think that's a good thing to aim for. And then also you're not just treating one over the other. Okay, thanks. Thanks.
Can you speak in the microphone? Or maybe...
Yeah, on that, I think VS Code, I think already has like a bridge for like the LSP being like giving context to like Copilot or something. So that's that.
Yeah, and I think Thibaut's got a LSP MCP integration as well. So it might be something that we can kind of coordinate more broadly.
So I work on the type error messages for ML, and we have a problem, which is that we have a way of exhaustively explaining all the places that could be wrong in the program, and of course that's way too long for humans, so we explored various ways of summarizing it or eliding some parts. For the LLM, it might not be a problem, right? You can just give the full thing. And
how long are we talking about, though?
Well, so maybe it could easily be 20 lines, 30 lines of...
Oh, that's not too bad. Yeah. I mean,
right, yeah, it's bad for humans,
yes.
But for LLMs it would maybe be better, right?
Yes.
Mm-hmm. Okay, so that's good.
And there is also the possibility that you could have a tool that, say, spawns off a sub-agent that takes that error message and summarizes it and actually figures out which bits are relevant,
Right.
And it doesn't pollute the rest of the context. For the
So I've heard that they've implemented our system in a company I won't name because this is internal knowledge, but the users didn't find it better than the existing tool, which was very finely tuned for years, but they made our system better by using an LLM to summarize these error traces. So exactly what you're saying.
Yeah, thanks for the talk. It was great. It's still unclear to me because I've experienced this problem numerous times when LLM generates you usage of core or base, and you're not dependent on those things. You have vanilla OCaml. How can we solve that part in general?
That's a good question. I mean, I'm not 100% sure how we stop them doing that. I mean, something that we noticed in our own experiments. It may be something. MCP also lets you have prompts, and in fact, they've just added some functionality to Claude like yesterday, which is skills. Yeah. And it may be that that's something that you can address by prompting it and saying, like, actually, these are the packages you have available, and like, don't use core if core's not there.
Yeah, I mean, it's also like you can have Dune package and Dune MCP, and then just given the list of packages that you have, that's also, I guess, the option that we can take. Yeah, thank you.
Again, this is really late-breaking news. Skills only appeared in Cloud Code 18 hours ago, so I have got it working, where you can encode the folklore in your dependency graph as a skill. So I say, if I'm doing a JSU application, I know I'll need to depend on LWT. Don't depend on async, for example, unless you're using Bonsai. And so we can actually, if we wanted to, have an OPAM package of all of the skills for the dependency cones that the OCaml community knows about, and get the people who maintain those packages to maintain that. I think it'd be pretty cool to have one for the real world OCaml, one for the LWT community, one for EIO, one for whatever else is coming up. I think we'll only have about 5 to 10 of them, so it feels manageable. But it's a very new one, so I'll post and discuss and see what we can come up with for that.
Hi, thanks for the talk. I wonder if you found some shortcomings in tools that you think should be addressed to help this kind of flow. One experience I have is Dune. In watch mode and Dune diagnostics, they don't work very well for LLM because the build is not finished, but the LLM is already asking for the results. And I've wondered if there are other examples like this that you think should be addressed. I
think Anil's probably got some good answers to this one, because he's done a lot of OCaml vibe coding, like a lot.
In a nutshell, if you have parallel subagents, you really need locking. So the Dune RPC client is really good for this, because it will block the subagent until it finishes the Dune build. So configure it to use that. The rest of the tools, the LLM tries to figure out how to call them outside of Dune, and that's usually a disaster. So we need a little bit of reinforcement learning to encourage them not to call OCaml find, not to call OCaml-C directly, and always go through the Dune rules. So that's the data deficiency thing that Sadiq pointed out. I think the only answer to that is to generate loads and loads of examples of how to do this synthetically, and then pollute the benchmarks and so on with this to get that to work. But the golden rule is always go through Dune and use the Dune RPC client and call the Dune rules, and then everything seems to work out okay. If not, it's a disaster.
Okay, thank you.
Any other questions? You showed us a number for the amount of OCaml code in the training set, right?
Yes.
So it was 0.0002?
0.003. No, I mean, that's what I could find publicly. We don't know what the Frontier Labs have got internally. We don't know whether they're synthesizing code.
Right.
I
was curious if you have numbers for other languages like Haskell.
So if you go and you look at, if you Google for the Stack v2 archive, you'll find the paper, and that paper basically gives you the breakdown of how much code there is for the different languages. It doesn't actually mention OCaml. You have to actually find this paper where they synthesize additional code. They basically translate a bunch of Python code into OCaml to try and kind of scale up the amount of code, but then you basically end up writing Pythonic like OCaml. And that has some breakdown of the amount of OCaml code there is in the stack.
Okay, thanks. So you have no idea how much Haskell there is in there, or how much Scala?
Actually, Haskell is mentioned in the Stack v2.
Okay.
There, but I don't have the numbers off the top of my head.
All right. Thank you.
Do you know how many lines of code is this 0.003?
No. They give the numbers in megabytes, I think.
Okay.
And so, yeah.
Okay. Any other questions? So let's thank the speaker again.